Hello everyone. In this video, we are going to look at question Q5 of part 4 of our ROF homework exercise. According to the questions, we are given a planar dielectric waveguide with a core thickness 20 microns. Now, I have to tell you that in the version of the slide I've sent to the class, I have mistyped here. Here should be 20 microns, not 20 millimeter. 20 millimeter is too big for a optical waveguide. And the core refractive index is 1.455. The cladding refractive index is 1.44. The wavelength of the light propagating along the waveguide is 900 nanometer. This means 0.5 micrometer. Find all the propagating modes. Theoretically, you can just calculate the propagation constant for all the modes, and then the answer is given. But the answer that the suggested answer has besides the modes in angle, and I'm going to explain to you in a minute. So first, we need to calculate the V number. Using the information available from the question, you calculate the V number, and then with the V number, you find out all the normalized propagation constant for all modes. And then from the propagation constant, you work out the angle. Normally, this angle is the angle of incidence. At different mode, the angle of incidence will be different. Okay, now we are going to start now. So first, I'm going to switch you back to the whiteboard mode. And I'm going to remove it's a mess here. But this one, here, I found now. Okay, now the waveguide, according to the question, you have a waveguide like this. The core refractive index is 1.455. The cladding refractive index is 1.44. So imagine you have a particular mode. Modes means wave. Like as here. When the beam passes through the three-dimensional space, it has a wave number. It is associated with the wave number k of 1. Yeah, k of 1. Now, what we can do is we find out the value of b. The value of b, but in the formula, according to the formula, the value of b is n square minus n2 square divided by n1 square minus n2 square. And here we can work this out, and k naught square. And we have all the information. K naught is equals to 2 pi times the wavelength 0.9. So I got the value here. K naught is about 6.9813. So what we need to know is we use the angle of incidence to characterize the mode. So based on the information here, we know that the k of z is equals to k1 cosine, sorry, sine theta m. Yeah, because k of z is in this direction, and k of 1 is the wave description, the zigzag wave beam. So what we can do here is we can substitute k of 1. K of 1 is equal to n1 times k dot sine theta m. So from here we know that the theta of m is sine oxide, and then k of d, and then n1 k naught. So this is the way how we work out the incident angle out of the propagation constant. And the propagation constant can be evaluated from the value of b, which is the normalized the propagation constant. And now we can start now. So we substitute the value here, b, and then k, z, and then 6.9 A13 square minus n2 square 1.44 square, and then 1.455 square minus 1.44 square. So all we need to know is the variable b. With the variable b, we will have only one unknown in this equation. Say this is equation 1. You solve the equation 1 according to the value of b. Okay, and then from here we will use theta of m to work out. We'll use this formula to work out theta of m. Theta of m, according to here, is sine minus 1, and then kz, and then n1. But we have already got n1. N1 is 1.45. And then times k naught. K naught is 6.9813. So these are the things that we are going to be based on. So we, for the time being, I'm going to relocate the writing. Yeah, it's a little bit messy now. I'm going to relocate this one to pi 0.9 6.9813. So I'm going to use the little space on the right hand side to continue with this question. First, I need to know the value. So I need to know the mole number, and then we need to know the value of d. And then from there, I will work out the value of k. And then from there, I will work out the value of theta. Yeah, perhaps I need to increase the space a little. And then k, z, and then the theta m. So we will use this table and work this out. So we need to find out the value of V first. V is K naught D, and then square root of n1 square minus n2 square. K naught is 6.913, and then D is the thickness. It is 20 micron, right? And then 1.455 square. 1.44 square. So from what I have got here, the V number is 29, maybe just 29.96. Okay. So now I'm going to switch you back to the I will switch you to the BB part. The V number is 29.09. So I am going to switch to the whiteboard, to the BB part. So this is the BB part we have got. You can see, yeah, I will enlarge the BB part, yeah, enlarge it, so you can see it more clearly. Now, I'm now looking at the BB part. Down here, you can see the coordinate of the vertical axis and the horizontal axis. It's just XY coordinate. And the vertical line here represent V is equals to 29.09. So I have put the V number here. Now, the crossing between the vertical lines and the curve here represents the solution of B for a particular mode. For example, I'm now pointing at the crossing between the first family of curves and the vertical line V equal to 29. And according to what I got here, the value of B is 0.99. Okay, so I need to write this down. So this curve here represent Tm or Te0, and so I will write down 0, and the value of B is 0.99. And the next one is 0.954. So this is T more 1.954. And the fourth one, 0.907. 907. I have already written it down in the whiteboard. and 0.832. And here, and you need to point your cursor to the upmost curve. So 0.744. And here, you need to point the cursor in the upmost one, 0.636. And for mole 6, so it's about 0.507, 0.508. Let's round it up. And for mole 7, the p-value is 0.359. 7. And for this value, 0.198. So mole A 0.198. And finally, this one here, 0.031. So altogether, you have 10 moles. The largest mole is mole 9. Now, what I'm going to do now is to switch back to the whiteboard. So I'm going to remove it, or I can just delete it. Delete this graph. And then, now you are looking at the whiteboard. And I have already written down. I've already written down the normalized propagation constant for all the moles. This value, normalized propagation constant, is known as B in the PV curve, and all these numbers are extracted according to the causing between the PV curve and the vertical line V is equal to 29. And I'm going to calculate the value of KZ. I need to use GNU Optics to help me. So I can show you the GNU Optics code. So I am going to switch to Window, GNU Optics. So you are looking at the GNU Optics, the window of GNU Optics. I will make it small. A little bit messy. So now you are looking right at my window, yeah? So what I am going to do is to solve the question. So first I set the equation, and the value of B. I will use the starting one as I will start with the first one, and then times, and then the formula for the KZ for the value of B, and then K naught, and then square, and then minus N2 square. I am not sure whether it will work. N2 square and divided by N1 square minus n2 square. I have already pre-stored the value of n1 and n2 and k0, so I don't anticipate any problem. Okay, I got it now. So the next thing I'm going to do is to solve the equation for kz, and I need to make sure the final answer is a numerical value. So from here, I got the value 10.15, and this is not enough. I need to work out the angle as well. The angle is beta m. This is the incident angle. A sine, remember the formula, yeah? And then 10.157 divided by divided by n1 and k0, and I need to change it to degree. So the first one is 89 degree, 89.2, and the value of k is 10.15. 89 degree. And I'm going to solve the second one. The second one has the value of b equals to 0.954. And then I'm going to solve the value of kz. So I got 10.153. The angle so 153. So 88.23. And I'm going to solve for the next one. The b value is 0.907. So I change the value, the b value, 907. And then I'm going to solve it for the value of k. The value of k is 10.148. So this is mode 2. And then I need to work out the value of theta. So I need to change it for A. And then, so it's 87.48 degrees. And the process will continue. And the value of B for mole number 3 is 0.832. A32. And I need to work out the value of propagation constant, 10.14. So I write it down, 10.14, and the angle corresponding to this is 86.6 degrees. So the process will continue. And the value of B for mole number 4 is 0.744. And I'm going to work out the value, I need to solve for KZ first. So 0.131 and the angle 85.84. And I'm going to look for for mole 5, the value of B is 0.636. 636. And then I'm going to solve for KZ. And I got 10.12. And I'm going to solve for the theta m, the incident angle corresponding to this mole. And then I got 85. And now I'm looking at mole number 6. The value of B is 0.5. And I need to solve the KZ. The KZ is 10.1. 10.106. And I use this value to work out the angle of incidence. And I got 84.21. And the value of B for mole 7 is 0.359. And I need to solve for the propagation constant. It's 10.09. And I'm going to use this to work out the angle corresponding to this propagation constant. And I got 83.43. And for mole number 8, the value of B is 0.198. So I need to change this. 198. And from here, I can get the value of Z, KZ, 10.07. And from here, I can work out the incident angle corresponding to this mole. Is 82.64. And finally, I will look for the largest mole. Mole number 9. The value of B is 0.031. And from here, I can work out the beta k of z is 10.056. And I will use this value to work out the angle 56. The angle is 81.88. So this is the answer of the question, and I'm going to show you the. So this is the right board, and I have already tabulated the answer. The uh, propagation constant is on the third column, while the angle corresponding to the propagation constant is in the last column. And you will see that the first five angles are exactly the same. I can show you again uh, the angle. So let me show you. I will show you the answer. So this is the answer. The answer only the last three value. Now the last angle 89 correspond to uh, 89.2, and the second one 88.34, which is exactly uh, 83.34. Sorry, 88. Yeah, I got 88.23. So very close. The next one, I got 87.48, while the answer is 87.52, and the next one is 68.68 from the answer, but I got 68.6. So the answer are quite close. I only copy the last formal because I actually extract the answer from the graph from the internet. But here you can see where we can calculate the value directly from the BB curve. Anyway, if you have further questions, please leave your comments to the comment section, and I am more than happy to help you. Thank you. Bye bye.